Hi, you guys. This is Miss Johnson, and we are in Unit 4. We're talking about bonding, and this is polarity. So all of the valence electrons are going to do all the bonding, and I circled them on this periodic table, and you have them on the top of the ones that you made with me in class. So all of those numbers that I circled, those are all of the valence electrons for the atoms and going in the vertical columns beneath. So when we're going to draw Lewis structures, the first thing we do is we fill in the valence electrons in a four-way quadrant. And our example is carbon. On the periodic table, you can see that all of those vertical atoms have 4 valence electrons. So I'm going to draw them in 1, 2, 3, and 4. It's just that easy. Whee! And then when we draw the atoms next to each other and we fill in all their valence electrons, we're going to draw a line between the 2 single dots from each atom. And this line is telling the audience that they are sharing. And this way they both fulfill their octet rule for chlorine and duet rule for hydrogen. So these values are the Pauling scale values, and they tell us how electronegative an atom is. We're always going to look at 2 atoms at a time, and we're just going to do simple subtraction to see if they are polar, nonpolar, or ionic. And these are our values for polarity and nonpolarity and ionicness. So when we have a polar molecule, when we calculate a polar molecule, we're going to draw vectors pointing from the least to the most electronegative atom. And that's just this little arrow here in purple. Whee! And then we're going to also draw dipoles, which are the little lowercase deltas that you see, those little squiggles with a minus and plus. That's lowercase delta. And what this is telling our audience is that there is a partial charge. These dipoles mean that there's a little bit of charge, a little bit of positivity, a little bit more negativity. And they're imbalanced, right? So here's a couple more examples. In our first example, we have 1 sulfur atom and 2 hydrogen atoms. And I calculated their values, and it ended up polar, so I'm drawing in my valence electrons for sulfur, and I'm going to draw in my valence electrons for hydrogen, make my line. That one's done. And then I go over here, do the same thing. Nitrogen has 5 valence electrons, and each of those chlorines has 7. You just don't want to forget that if you calculate that a molecule is nonpolar, you do not draw vectors or dipoles. You don't have to do it. So the thing is, when 2 vectors point towards each other or away from each other, they're going to cancel out, because it's like playing tug of war, right? If you have like a dog that you play tug of war with and they have a chew toy, if you guys are pulling with the same force, that chew toy doesn't move back and forth. And the chew toy in our example is the electrons. So if we're both pulling with the same amount of force, the electrons don't get pushed or pulled one way or the other. So there's no net movement. And so that's why we draw a line through those vectors, showing the audience that they canceled out. So the ones that don't cancel out, don't forget, you do have to draw a vector and a dipole for. In this example, we're looking at hydrobromic acid. And the bromine is more electronegative than the hydrogen. When you calculate the bond between them, it ends up being polar. So you're going to draw a negative dipole on bromine and a positive one on hydrogen. So on the left, we have methane. And when you calculate the electronegativity values between carbon and hydrogen, you should end up with a polar bond, but when you draw the vectors in, they all cancel out and oppose each other. So this makes the molecule nonpolar. On the right with phosphorus trichloride, the same thing happens to the chlorines on the left and the right. They both cancel out, but polarity does exist between the phosphorus and the chlorine underneath. So since chlorine is more electronegative than phosphorus, we draw the negative dipole on the chlorine and the positive one on the phosphorus. So in this example, we're going to look at water, we're going to look at sulfur dichloride, and then we're going to look at cyanic acid. And on the first one, I'm going to draw the molecule, or I'm going to draw each valence electron in one by one. And oxygen has 6 valence electrons, so that's 5 and 6. Whee! Those are the one valence electron for hydrogen. We have 2 different hydrogens, so I drew the bond. When I calculated the value between hydrogen and oxygen, I calculated a polar bond, so my vectors point towards oxygen since it's more electronegative. And then the negative dipole goes on oxygen and the positive one's on hydrogen. This example of sulfur dichloride, sulfur has 6 valence electrons. Each chlorine has 7. So I'm drawing those in right now. Yay. And then I'm going to draw the line between sulfur and chlorine, shows that they're sharing. When I calculated the value between chlorine and sulfur, I ended up with a polar bond. This time chlorine is more electronegative than sulfur, so the vectors point towards chlorine, and the negative dipoles both go on the chlorines. Then for my last example, I've got 4 valence electrons around my carbon, and it always goes in the middle. I have 5 valence electrons around nitrogen, and I have 1 for hydrogen. I draw the line between my atoms, and then I get left over these 2 little single electrons from different atoms. So what I'm going to do is I'm going to rearrange them and put them in the middle, just like we did in class. So here we go. Oh, they disappeared and now they reappeared. Yay. And then, oh no, I have the same problem. 2 more that are still left. And I'm going to do the very same thing to those. I'm going to erase them and rearrange them, put them in the middle between carbon and nitrogen. And when I do that, my octet rule is fulfilled for both nitrogen and carbon, and my duet rule is fulfilled for hydrogen. When I calculated my electronegativity values, there's polar bonds between carbon and hydrogen and carbon and nitrogen. So the negative dipole goes on nitrogen and the positive one on hydrogen. So keep practicing. Don't forget to do your homework. Don't give up. Chemists try. And have a great rest of your day. Yay.